Hello again. We are continuing our discussion of inequalities by talking about what happens when there's absolute values in those inequalities. So we talked about this with equations. So let's try and recall what we talked about when we were solving equations that had absolute values in them. Let's look at an example real quick. Absolute value of 4x plus 5 plus 1 equals 10. Now remember, the first thing we had to do was get the absolute value by itself, which means in this case the plus 1 has to go away. So I'm going to add negative 1 or subtract 1 from both sides, and I'll get absolute value of 4x plus 5 equals 9. Okay. Once I have the absolute value by itself, I split this into two equations. For the first one, I'm just going to drop the bars and solve it like any other equation. So it's 4x plus 5 equals 9. If I add negative 5 to both sides, I get 4x equals 4. And then if I divide both sides by 4, I get x equals 1. Okay? Then I work on the second equation that's created by this, and to do that I drop the bars, but this time I change the sign of the other side and I solve. Okay, so 4x plus 5 equals negative 9 instead. Add negative 5 to both sides and I get 4x equals negative 14. Divide both sides by 4 and I get x equals negative 3.5. So now let's talk about inequalities. The steps are very similar, but there's some small changes. So I'm taking the same thing that I started with when I was talking about equations, but I've just changed the equal sign to a less than sign. So I'm still going to solve for the absolute value, get it by itself, which means that the plus 1 still has to move. And I will get that the absolute value of 4x plus 5 is less than 9. And now I split it into two inequalities instead of two equations. So for the first one, it's still dropping the bars and solving it. It's just that we have an inequality instead. But I already know how to solve those. So I have 4x plus 5 is less than 9. And I will add negative 5 to both sides so that the plus 5 and the negative 5 cancel out on the left, and I get 4x is less than 4. If I divide both sides by 4, I get that x is less than 1. So here are all the numbers that are less than 1. Notice I've used a hollow circle because I'm not including 1. For the second part of the inequality, I'm going to drop the bars again, and I'm going to change the direction of the inequality sign and change the sign of the number on the other side. So instead of 4x plus 5 is less than 9, it's 4x plus 5 is greater than negative 9. So I've changed both things. Okay. Still solve it. I'm going to add negative 5 to both sides so that the plus 5 and the negative 5 cancel out, and I get 4x is greater than negative 14. Divide both sides by 4, and so notice that when I'm dividing by a positive 4, I don't need to change the inequality sign, and x is greater than negative 3.5. So here's all the numbers that are greater than negative 3.5. Since there is an overlap here, this is going to be an AND situation. It's going to be an overlap. It's going to be an intersection. So I have to graph the numbers that were graphed both times when I graph the purple and the dark red solutions there. So the solution is x is greater than negative 3.5 and x is less than 1. Or I can write it like that, but I graph it like that. Okay, those are the numbers that were graphed both times. Okay, so I'm going to check my answer, and I always need to do this just to make sure that I've gotten things right, because bad things can happen, and we'll talk about those a little later at the end of this video. So what I'm going to do, there's my solution, or there's my inequality that I started with, and I think that that's my solution. So what I'm going to do, you'll notice that there's a section in the middle that represents my solution, but there's sections on the left and the right that are not part of my solution set. So I'm going to pick a number that is outside the pink region to the left. I'm going to pick a number that is inside the pink region. And I'm going to pick a number that is outside the pink region on the right-hand side. Now, I don't expect my red choice and my blue choice to work, but I do expect my green choice to work. So let's be careful about how we select those. So I'm going to pick negative 5. It's a random number that's to the left of the pink region. I'm going to plug it in so that my inequality reads absolute value of 4 times negative 5 plus 1 is less than 10. So I'm going to simplify all of that and make sure that it is false. I want that to be false. So simplifying the stuff inside the absolute value gives me negative 15, and the rest stays the same. Well, the absolute value of negative 15 is 15. 15 plus 1 is less than 10. That's obviously false. So good, the number outside on the left didn't work. Now let's pick a number that's inside the region. I randomly choose 0, and I plug that in for x in my original inequality. So 4 times 0 plus 5 in absolute values plus 1 has to be less than 10, and this one does have to work. Okay, so 4 times 0 plus 5 is 5, so that's what stays in the absolute value, and the rest stays the same. The absolute value of 5 is 5. 5 plus 1 is less than 10, and that x value worked. Now I'm going to pick a number that is outside the pink region to the right, and I'm just going to randomly choose 4. So 4 times 4 plus 5 goes in the absolute value, plus 1 is less than 10. If I simplify 4 times 4 plus 5, I get 21. So the absolute value of 21 plus 1 less than 10. Well, the absolute value of 21 is 21, plus 1 is less than 10. Well, that's false. We can see that 21 plus 1 is clearly not less than 10. And I didn't expect that one to work because it's outside the pink region. So I've picked 3 numbers just to make sure that the region that I've selected as my solution set is actually the solution set. Just a quick way to do that. All right, here's another example. If I have 5x minus 8 inside the absolute value, plus 1 greater than 3. So I first have to solve for the absolute value, which means I need to add negative 1 to both sides, and that gives me absolute value of 5x minus 8 is greater than 2. So I split it into 2 separate, that should read inequalities, not equations. So first I'm going to drop the bars and solve. So 5x minus 8 is greater than 2. I'm going to add 8 to both sides just to get the x's by themselves, and the plus 8 and the minus 8 will cancel. And so I have 5x is greater than 10. Divide both sides by 5, and I get x is greater than 2. So there's all the numbers that are greater than 2. Notice again the hollow circle, meaning that 2 is not included. For the second inequality, I'm going to drop the bars again, change the direction of the inequality sign, and change the sign of the number on the other side. So instead of 5x minus 8 is greater than 2, it's 5x minus 8 is less than negative 2. And I solve. Add 8 to both sides to get rid of that minus 8. The plus 8 and the minus 8 cancel out. So I have 5x is less than 6. Divide both sides by 5, and I get x is less than 1.2. So those are all the numbers that are less than 1.2. So notice how there's no overlap this time. Okay? So this is going to be an OR situation. So x is greater than 2, or x is less than 1.2. Since there are no numbers that are greater than 2 and less than 1.2, I have to treat this as an OR situation. There's no overlap, so this is a union instead. All right, so those are my solutions. Again, I've got 3 regions that I'm talking about. There's the region that's covered by the left pink arrow, there's the region in between the arrows, and then there's a region used by the right arrow. Okay? So here's our what I think my solution is. I'm just reiterating that from the previous slide. So I need to pick 3 numbers to check my answer. One of them is going to be on the left arrow, and it's going to work. One of them is going to be between the arrows, and it's not going to work. And one of them is going to be on the right arrow, and it is going to work. Okay? So the red number I've decided to pick is 0 because that is covered by that left pink arrow, and I'm going to plug x equals 0 into my original inequality. So it reads 5 times 0 minus 8 plus 1 is greater than 3, and I'm expecting this to work. So if I simplify this stuff inside the absolute value, 5 times 0 minus 8 is negative 8. The rest of it stays the same. The absolute value of negative 8 is just 8, and 8 plus 1 is greater than 3, so that worked. Now I'm going to pick a number that is between the 2 arrows, and I randomly picked, there's not a lot of room between 1.2 and 2, so I had to choose a decimal, so I picked 1.4. So 5 times 1.4 minus 8 plus 1 is greater than 3, and I'm not expecting this one to work because it's not covered by the 2 arrows. So if I simplify the stuff that's inside the absolute value, I get negative 1. And the absolute value of negative 1 is 1, and 1 plus 1 is greater than 3. Well, that's not true. That's false. Okay, so now I pick a number that is outside or inside the other pink arrows region, and I'm just going to randomly pick 4. So 5 times 4 minus 8 is inside the absolute values, plus 1. I'm hoping that that's greater than 3. If I simplify the stuff that is inside the absolute value, I get 12. 12, the absolute value of 12 is 12, and 12 plus 1 is greater than 3. That's true. So I think that I have more confidence that my solution is correct. But I have to be careful. There's one thing I need to warn you about. Okay, if you ever get a question where you have an absolute value less than or equal to a negative number, or an absolute value expression that is less than a non-positive number, then there's no solution to that. And the reason is, we've talked about absolute value, and absolute values are always 0 or bigger. So if you get an absolute value that's less than something that's 0 or negative, then there's no situation where that happens. That's just a number sense. It's a logical conclusion that you have to come up with, okay? Because absolute values can't be negative. So if I have something like the absolute value of 12x plus 3 is less than or equal to negative 34, well, there's no x I could plug in there, so that when I take the absolute value of that, I get something that is lower than a negative number. So there's no solution to that. There are no numbers that have an absolute value that's less than or equal to negative 34. Similarly, if I have something like absolute value of 35x plus 47 being less than 0, well, that's negative numbers. I can't have an absolute value that is less than 0. So there's no solution to that either. Okay, I will ask you some questions like that, and you need to use your logic and number sense to figure out that there's really no solution to those. So be careful of that. Don't go through all that process if you can just look at it and see that there's no solution. All right, so those are inequalities with absolute values. If you have any questions, please let me know, and I will see you tomorrow.